Let's look at the graphs of tangent, cotangent, cosecant, and secant. I will only do a couple of these, just to give you an idea. Now, in this chart, you'll see all the function values of each of those functions for the important angles, which are also found on the unit circle. And I'm going to use these to actually draw a graph of the tangent. So let's go ahead and draw y equals tangent x. Now normally I would just use 0, pi halves, pi, 3 pi halves, and 2 pi. But I'm going to have to use more values than that. So specifically I might use 1 pi fourths, 3 pi fourths, 5 pi fourths, easy for me to say, and 7 pi fourths. And so let's go ahead and look at our unit circle. Remember, we're doing tangent, and tangent is the same as y over x. And that is an x. I promise you that it is. So when we do y over x for at 0 over 1 is 0. So we're going to plot there. And then let's just do pi fourths. Just go around a circle. Anything divided by itself, pi halves, or square root 2 over 2 divided by square root 2 over 2 is 1. So I'm going to make a note and put 1 there, and then mark a 1 there. And then at pi halves, y over x, 1 over 0 is undefined. So that means that at pi halves, the curve isn't going to exist. That's going to be an asymptote. So we're going to use an imaginary vertical line to show that the curve does not exist there. Let's go to 3 pi fourths. And at 3 pi fourths, we have square root 2 over 2 divided by negative square root 2 over 2, which is the same thing as negative 1. So let's put my negative 1 down here and plot there. And then at pi, 0 over negative 1 is 0. Let's look at 5 pi fourths. Negative divided by negative is a positive, and anything divided by itself is a 1. So that's a positive 1. And 3 pi halves. Negative 1 divided by 0 is not possible. So 3 pi halves, we have an asymptote once again, an imaginary line that the curve approaches but never gets to. Let's look at 7 pi fourths. Same thing divided by itself, so we have one negative sign, which makes it a negative 1. And then back to 2 pi, which is going to be 0. 0 divided by 1 is 0. Now, if you know anything about the nature of asymptotes, you know that that means that the curve is going to approach, and then it's going to approach. And that's what's actually going on. It's approaching. We could use additional points. We could have used the pi thirds, 5 pi 6. But that's essentially what's going to happen. Now normally when we graph tangent, we'll actually go to negative pi halves, which means I'm going to use pi fourths. So normally we just graph negative pi halves to pi halves, because that's actually one cycle, or one period I should say. And we do that so you can see the negative values. So let's look at negative pi fourths. Negative pi fourths means we go this way, so it's going to be 7 pi fourths, and that's going to be a negative divided by positive, which equals negative 1. And then let's look at negative pi halves, which goes this way. Negative 1 divided by 0 is impossible. That's an asymptote. And so That's how it looks. So we typically graph from negative pi halves to pi halves. And as you can tell, if we just look at from like 0 to pi, starts there, and then from there to there, it goes back up to pi to our original starting point. So it has a period of just pi before it starts to repeat itself. You can see that it repeats itself there and then it starts there. So from 0 to pi. So a lot of times you just use negative pi halves to pi halves, so you can see that solid curve, a continuous curve. Now some things you want to be aware of. And by the way, we can always use your calculator to help us to verify that. So first thing we want to do is go to mode. Make sure it's in degrees. Then go to y equals. We're going to just graph tangent x. And once again, if you've watched my previous videos, you know that I should have went to zoom 7 for zoom trig, which makes it a lot nicer graph. And this is now in degrees. And you can see all this information. Now this pi force is the same as 45 degrees. So if I hit trace, then 45, enter, you'll see the value of 1 that I plotted. And if you want to do 60 degrees, just so you can see why it's going up the way it is, that's 1.7. So it's going to put it somewhere up here. And then if you want to do pi halves, which is 90 degrees, you're going to see something interesting. Nothing. That means it doesn't exist. That's why I have the asymptote. And since I do have the asymptote of pi halves, the domain is going to be all x such that x cannot equal, and let's look at this, it's pi halves, that's 1 pi halves, 3 pi halves, it's actually going to be 5 pi halves, but these are all odd pi halves, and that's a negative 1. So what it means is that x is not going to equal pi halves k, where k is an odd integer. You're going to see that quite a bit. So x cannot be pi halves. It's actually going to be pi halves k, where k is an odd integer. And just in k, for example, if you take any odd integer like 1 times pi halves is pi halves. Doesn't exist. Take odd 2s and odd 3 is odd. So 3 times pi halves is 3 pi halves, and it doesn't exist there. And if you use a negative 1 times pi halves is negative pi halves, it doesn't exist there. So that's why the domain is what it is. And then the range, just take any one of these curves. How far down does it go? Negative infinity. How far up? Positive infinity. And so that's what a lot of this information is going to say down here. And you can read that for yourself. And you might want to notice the x-intercept is at 0, 0. It's actually at every pi value, even pi. Or even every pi, not just even, but every pi for any integer. Vertical asymptotes, we already talked about that. And so the period, we gotta make a special note about this. The period is t equals pi over omega. And the reason why it's just pi is because the period of tangent is pi. The omega can influence it. That's going to be true for cotangent also, so be aware of that. You can use your calculator for find the graph of cotangent, cosecant. I want to look at secant. Now keep this in mind. Cosecant goes back to 2 pi over omega, as well as secant does also. And it still has the period of 2 pi, as well as cosecant does. It's just tangent and cotangent are a little different. We don't have to graph as much. So let's just look at the secant. And in fact, I'm going to make it even easier for you just to save a little time. Let's just go to our graphing calculator. And secant, when we graph secant, we're going to type in 1 divided by cosine x. And you'll see something like that, which is what's drawn here. And we'll go to a blank screen, or blank graph, I should say. And so I'm going to put in my pi halves and my pi, 3 pi halves, and 2 pi. I'm going to go ahead and put in negative pi halves. If I need to use pi force, I will. And negative pi. And so since y equals secant x is the same as 1 over cosine x, I'm looking at 1 over the y values. And once again, or x values I should say, because cosine is x's. So 1 over 1 is 1, and that's at 0. And then 1 over 0 is undefined, so I'm going to have an asymptote here. 1 over negative 1 is negative 1. And then for 3 pi halves, negative 1 over 0 is undefined, asymptote. And by the way, in case you haven't figured out by now, everywhere you see pi halves, or odd pi halves, asymptote. And then 2 pi is going to put us back up here. But let's go ahead and just make sure. 1 over 1 is 1. Now we will definitely need some additional points. I'm going to go ahead and look at my calculator, what I've already got drawn. And so what it's going to tell me is that in the middle that we have a curve that's doing this. Then over here it's doing this. And then same thing over here. And then at negative pi, this negative pi would be down here, or over there I should say, which puts us back at 0. Or not at 0, because I'm doing 1 over negative 1, which is negative 1. So it's going to look like this. And once again, you can use your trace just to verify that's a 90 degrees. X equals 90. Oh, it's not defined. I got a little confused there. Now I was looking at pi. I think pi was 90. Pi is 180. Pi halves is 90. So that's why there's no value. Then you do 180. Negative 1. And that's 270. And you can do not just 190 or 90, you can do 120. Just so you can see that 120, which is right here. It's going to put it about negative 2 down there. I'll plot that so you can see it. Just to give you an idea. You can use additional points. But let's talk about this for a second. The domain, as you can tell, it doesn't exist at the odd pi halves. So once again, it's going to be x such that x is not equal to pi halves k, where k is an odd integer. And then the range is kind of interesting. How far down does it go? It goes down forever. That's an ugly infinity. Looks like an 8. Don't want to confuse you. Then it goes up to -1. And then it skips from -1 to 1 and starts back at 1. And I should include that -1 because it's there. It does exist at -1. It was a value. So let's make sure we put brackets there. Then it skips from -1 to 1 and starts back at 1. And 1 does exist. The function does exist at 1, or has a y value of 1. So it'll be 1, then it goes forever up. Back to infinity. And that's what all this information says. And you can read that for yourself. But a lot of it you're going to understand a lot better when we do some examples. So let's just graph y equals 3 tangent x. Now the first thing I want to do is find the amplitude. The amplitude is the absolute value of 3, which is 3. And the amplitude of 3 will cause the y values to be increased or stretched vertically by a factor of 3. Now what else I want to do, I need to find the cycle, or the period I should say. And the formula we're going to use isn't t equals 2 pi over omega, but pi over omega. This is for tangent and cotangent, because they have a period of pi, just a regular tangent cotangent do. Now omega is the number in front of the x. If you don't see anything, it's always a 1. And so for y equals 3 tangent x, the period stays at pi. And so we need 5 points to plot or to graph. And the first thing we're going to do is find 5 points just for y equals tangent x. Since it is from 0 to pi, and I want to break it down with 5 points, which is 4 intervals, I'm actually going to use 0, pi fourths, pi halves, 3 pi fourths, and pi, because those are by far the easiest ones to use. And so that's what we're going to do. That's what we're going to use. So we're going to use 0, pi fourths, pi halves, 3 pi fourths, and pi. And those values for tangent is 0. If you look at the unit circle, y over x is 0. For pi fourths, anything divided by itself is 1. And probably I've already done this once before, but it doesn't hurt to do it again. Just want to make sure you understand where it's coming from. And then pi halves is 1 over 0, which is undefined. So I'm going to use this notation showing that it's undefined. And 3 pi fourths is anything divided by itself, but 1's a negative is a -1. And then that pi, 0 divided by -1 is 0. And you can also use your calculator, and I'll show you that here in just a second. But remember that we're graphing y equals 3 tangent x. So, since the period is the same, 0 to pi, we're going to use those same values, same x values. And to get the y values, all we're going to do is multiply each one of these by 3. Can't multiply that by 3, it doesn't exist. So 0 times 3 is 0, 1 times 3 is 3. That's still undefined. -1 times 3 is -3, and that's 0. So I'm going to use those points to draw a graph. So let's go to blank graph. using 0, pi fourths, pi halves, 3 pi fourths, and pi. I want to make sure I'm looking at the right things. Now, I'll see this at pi halves is an asymptote. So I'm going to draw an asymptote at pi halves. And then that's going from 1 to negative 1. And you'll see that the values that we have are 0, 3, negative 3, 0. 0, 3, negative 3, 0. 0. And I should actually label those as 3. 0, 3, and then this one is negative 3, this one is 0. So it looks like this. So I know how it's going to look with the asymptotes. So that's one period. Now if you want to, you can keep on going. Watch this. 1 pi fourths, 2 pi fourths, 3 pi fourths, 4 pi fourths. This is going to be 5 pi fourths. This would be 6 pi fourths. This would be 7 pi fourths. This would be 8 pi fourths. So we can extend it as far as we want. But if you look at this, we know that it's going to, from there, here to here is the same value. So it's going to take off again. And also notice that pi halves, that's an odd pi halves. We're going to have an asymptote there, because that's another odd pi halves. And then if you notice that at every pi, 0 pi, 2 pi is going to be a 0. So you just get a rough estimate. And you can also extend it this way. This negative pi halves is an odd pi halves. Asymptote. And once again, we can always take out our calculator. And remember what this graph is. This graph is y equals 3 tangent x. So 3 tangent x. And once again, we're just gonna verify a few things. Pi fourths is the same as 45 degrees. I'm still in degree mode. So if I trace 45, enter, you'll see the value of 3. And if I do pi halves, which is 90, you'll see nothing, asymptote. And if I want to do 3 pi fourths, which is 135 degrees, you'll see the negative 3. So it just confirms what we just drew. So let's do another one. A secant one this time. We'll make this a little bit smaller. So let's do our amplitude. Absolute value of 4 is 4, which means it's going to increase all of our y values by multiplying by 4. Let's do the period. This time we're going back to 2 pi over omega. So it's going to be 2 pi over 1/2, which is the same as 2 pi times 2, which is 4 pi over 1, which is 4 pi. So that means we're going to go from 0 to 4 pi when we graph this. I mean, that may be all that I do. But before I do that, we need to talk about the domain and range, don't we? So let's talk about the domain, because you're going to see this. Domain, notice where the asymptotes occur. They occur at every odd pi halves. So the domain is all x such that x does not equal pi halves k, where k is an odd integer. Good thing I remember this. This is for your benefit. And then the range goes down forever and goes up forever. Negative infinity to positive infinity. All real numbers. Now let's go back. So our amplitude is 4. We did 2 pi over omega. Once again, the omega is what's with the x inside with the x. And furthermore, with the x's, it's always opposite what you think. Instead of shrinking it by 1/2, it's going to actually increase it by a factor of 2. That's why when our normal period is 2 pi, but when we increase it by a factor of 2, it's going to make it 4 pi. And so we're going to do y equals cosine or secant x first. And we're going to use, since we're doing 2 pi, we're going to go back to our quadrantal angles. So it's going to be 0, pi halves, pi, 3 pi halves, and then 2 pi. Secant same as 1 over cosine, so which is the x, so 1 over 1 is 1. And then for pi halves, x is 0, and 1 divided by 0 is impossible to do. Asymptote. Undefined. 1 over negative 1 is negative 1. 3 pi halves. 1 over 0 is undefined. And 2 pi is the same as 0, so it's 1. Now, we actually want to do y equals 4 secant 1/2 x. Now, to do this, we need our x and y points once again. To find those, for the x's, notice what I said about the 1/2. It's going to stretch it horizontally by a factor of what you not what the number isn't, but it's reciprocal. Or in other words, by a factor of 2, which means we're going to take this 0 and times it by 2, and we get 0. Then we take pi halves times 2, and those cancel out, leaving pi. Then take pi times 2, and we get 2 pi. Then take 3 pi over 2 times that by 2, and those 2's cancel out, leaving 3 pi. Then times 2 pi by 2, and we get 4 pi. And I do believe this is the easier way. I may have shown a different way in another video. It's the easiest way. And we do end up at our 4 pi. And then, remember what the 4 does? It makes all these y values bigger. So we multiply those by 4. So 1 times 4 is 4. Can't multiply something that doesn't exist by something. So it stays as it doesn't exist. Negative 1 times 4 is negative 4. That doesn't exist. And 1 times 4 is 4. So we're going to use these points to draw the graph of y equals 4 secant 1/2 x. Y equals 4 secant 1/2 x. So once again, we're using 0 pi, 2 pi, 3 pi, 4 pi. 0. Oh, I got excited for a second. 0 pi, 2 pi, 3 pi, 4 pi. And what's the numbers we have? 4, negative 4, 4. I already forgot. 4, negative 4, 4. 4, negative 4, 4. These were asymptotes. And it's going to go up this way, and it's going to go that way. and it's going to go this way. Not the most accurate of graphs, but you get the idea, I hope. And we can always extend it if we want to. And here's the way we can do it. See these pi's? It goes 1 pi, 3 pi. This is going to be 5 pi. Asymptote. And then I can always go this way. See that pi? This is going to be negative pi. Asymptote. And I can keep on drawing the graph. And once again, we can always use your graphing calculator and type in 4 secant 1 half x, which is 4 1 divided by cosine 1 divided by 2x. Notice how I typed that in. I don't have a secant. That's actually not correct, by the way, because I need to put a times in there because it looks like 41. Second insert times. Let's see how that looks. What happened here? I probably need to change my window. 4 pi is the same as 4 times 180. So let's do our max is 4 times 180, which is 720. And then our x min, we don't want to make it, or y min, we don't make it negative 4. Let's just make it negative 20. I didn't put my negative sign in. And then the y max, let's make it a positive 20. Now you can see it. You can see the asymptotes. The graphing calculator actually draws in the asymptotes. And so let's just confirm some things. At 0, we have our 4. Pi is the same as 180 degrees. We get nothing, undefined. 2 pi is 2 times 180, which is 360. And you see that nice negative 4 flashing. And if you want to, you can do even 90. And you see it's up here, and that's why the curve goes up that way. So it tells you, it just confirms what we drew on paper. What we want to do now is find the domain and range. Domain. If you notice, the domain is going to be all x's except for where the asymptotes exist, and they exist at pi, 3 pi, 5 pi. Let's catch that. That's all the odd pi's. So it's going to be all x such that x does not equal, and we're going to use k pi, where k is what kind of an integer? Well, 1, 2 exists, for the evens it exists, but the odds it doesn't. Where k is an odd integer. And then the range, how far down does it go? It goes to negative infinity. How far up does it go? Negative 4. And it does get there. So bracket, union symbol, and then it skips negative 4 and takes back off again at 4 and goes forever to infinity. And the 4 is included, so we use a bracket for infinity. And that should be all there is to do.